Hello, let's continue our Sudoku adventure with Journey to Egypt by Strosahl. So we're tracing the path Mary and Joseph took when they fled to Egypt with baby Jesus. All right, so we're going to go from the 1 to the 5. Let's go over the rules. We have normal 6 by 6 Sudoku rules, so in each row, each column, and each 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have these clues outside the grid. These are sandwich sums. So, for example, this 9. What we need to do is we need to find where the 1 and 6 are in the row. So maybe the 6 is here and the 1 is over here. Then the digits in between them must sum to the clue outside. So maybe like a 2, 3, and 4. So 2 plus 3 plus 4 is 9. So that fulfills our 9 sum, and it is in between the 1 and the 6. Now, of course, we don't know where the 1 and the 6 are. So that's part of what we need to discover. All right. In addition to that, there is a path of orthogonally connected odd digits leading from the given 1 to the given 5. So we need to, orthogonal just means shares an edge. So we just need to create some kind of path where we only move up, down, left, right, and eventually make it from the 1 to the 5. And along that path, it is only odd digits, 1, 3, or 5. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So I think we should color even odd. Do we need to color even odd? Nah, we don't. Let's not start with that. So this 1 is one end of our sandwich. Now, this clue vertically is a 6. We know that we're not doing 1, 6, 6 with the 6 in the middle of the 1 and 6, right? That would be the 6. So that means we need at least 2 cells to add to 6. Now, what would happen if we used 3 cells to add to 6? Well, it would have to be 1, 2, 3, but the 1 can't be involved in the sum. So actually, it is 2 cells adding to 6 with then the 6 here. And these 2 cells can't be 1 plus 5 because 1 is never in the sum, right? 1 and 6 are never part of the sum. And so actually, we are limited to just 2 plus 4. Now, the 9, we know that the 1 is not involved in the 9 sum. And so the only way to sum to 9 is 2, 3, 4 in 3. And in 2, we could be 3, 6, or 4, 5. So we could be 4, 5 in 2 with a 1 here, or we could be 2, 3, 4 with a 1 here. So that means definitely the 1's in one of these two. And then these 2 are always in the sum. So they're either 4, 5 or they're 2, 3, 4. So they're not, yeah, I guess they're just not 1 is the only conclusion there. So I don't know how helpful that is. I'm thinking about the 5 in this row. It's a little bit interesting because this 5 looks here. So this can't be the 5. If this was the 5, this is our 1, and this was supposed to be 4, 5, but it can't be 4, 5 or 3, 6 anymore. So this can't be the 5. This can't be the 5. If this was the 5, that doesn't, hold on, where's the 5 then? Okay, yeah, okay. If this was the 5, then this would be our 1. And now these 3 need to add to 9. But we had to be 2, 3, 4 to add to 9. We can't use the 5. We can't do 1, 3 here because the 1's gone. So the 5 is not here, here, or here. Meaning the 5 is over here, meaning we have to put the 1 here in order for this to be 4, 5. And now this is 2 and this is 4. That's really interesting how that worked out. Wonder if there was an easier way to think about that. This is a 2, 3 pair. Down here we need the 3, 5. And so that we know the order. That's 3, that's 5. 3 in the corner celebrating. So this is part of our sum. Now we could go 1, 2, 6, or we could go 1, 2, 6. But the problem is this can't be a 2. Okay, so this is 2 and 6 to match this 2 sandwich clue. All right. Is that all our sandwiches? We have the 6 sandwich. Oh, we haven't done the 5 yet. So this could be just 5, 6. Sorry, like this, 5, 6. Or we can make these 2 add to 5 with a 6 here. Oh, but this can't be 6 anymore. You can't do 5 and 3. Definitely not. In fact, the minimum sandwich sum in 3 is 9. Because we have to do 2, 3, 4. So we can't even use the 1. So because we can't make this the 6, this is our 6. And then this is a 5. Gives us 4 and 5 here. All right, and so this is a 2, 3 pair. This is a 1, 3 pair. I think we're going to have to do the path soon. Down here we have 1, 2, and 4, and that can't be 2, and that can't be 4. This is 1, 2, 3, so the 6 goes here. Right, that was the only place for 6 in the box. This is 1, 4 only. Then over here we need 1, 3, 4. Okay, so I think we need to think about this path. Let's just get this triple as well. We need 3, 4, 5. That's not 4, that's not 5. Oh, 2, 3 pair actually makes a 5 there. That might be helpful. That's not 5. So from here, let's just start marking the path. I'll mark it in orange just to remind myself that it has to be odd. So we're definitely not going down. We only have 2 directions we can go because it's orthogonal. We're either going down or right, and down would be an even digit. So we're going to go right. Now from here, we can't go right, so we have to go down. And that means this better be odd. So that's 3 and that's 2. That's 1 and 3. That's 2. All right, over here we get the 4 and the 3. Let's get these pairs written out. So this is 2, 4, and this is 1, 6. And then this pair is 5, 6. All right, so that's 6, that's 5, that's 1, that's 6. That's not a 1. Oops, not a 1. All right. Now from here, we can go, I mean, it didn't say anything about the path being 1 cell wide. So we'll be careful here. We can't go left, we can't go right. So we're going to have to go down. Now here we can't go left or down, so we have to go right. Here we can't go up or right or down, or sorry, up or right. So we have to go down. Now here, it seems like we have a choice, but this is a wall here. This is a wall of evens. So if we go into this box, we're never coming back out. So we have to go right here. And then now the only direction we can go is right, and that makes this the 3. So that's 2, that's 4, that's 2, that's 3. And so now, I mean, if we went up, we'd get stuck. We couldn't move further. No, the 4 and the 6s are all even. So we're going to go down. So that's our 1, that's our 4, that's our 4. Let's finish the path first. We're going to go right and then down. All right, so we made it to Egypt, and that is our 1. Very nice. All right. Neat puzzle, Strosahl. I enjoyed that. I liked how we actually could do quite a bit with the sandwich, but then the path actually just fixed a bunch of deadly patterns we had. So that was nice. And you really didn't have to put many restrictions on how the path not touching itself or not backtrack, all that stuff, because there really was only one way it could go at every step, which was really interesting. It's very limited. If you're trying to make a path of odds from the top left to the bottom right, like it's going to look like this. There's only 3 odds per row, column, and box. So cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.